Hi folks, this is Karim Raouf from our IT Visualizer channel. We will continue our Lambda Matrix labs, the video number 121. We have been discussing in the previous video the following. We are still working with the cases that was created by Claude 3.5 Sonnet concerning how we can troubleshoot Windows using remote tools and especially focusing on command shell commands. Okay, we have seen two wonderful cases that was created by Claude 3.5, 3.7 Sonnet, and actually it's very creative, and actually I like the way Claude 3.5 Sonnet is creating the responses. Very creative, very code oriented, which is what I am focusing on mostly. All of the AI tools don't focus that heavily on coding, or maybe for example ChatGPT O3 Omni or Mini High Omni is focusing on that as well, but the best AI for coding is Claude 3.7 Sonnet. Okay, so we'll try now to see a third case concerning troubleshooting Windows using remote tools. Let's see the third case and try to read it out loudly. So here we'll go to projects, and then I have it on troubleshooting remote shell al commands, and then we have remote troubleshooting mastery, and then we will go to the third case. So here we have, actually I have even four cases, but now let me get to the third case. So here it is. This is the case of a sluggish application server. Maybe there is some relation between this case and another case, but it's not the same. They are, or it is from another perspective. So let's try to read this out loudly.
Pacific process is hammering the disk. Disk activity monitoring script. Click to open. The case of the sluggish application server. Scene 1. The hook performance complaints. 11:30 a.m. Monday morning. Mia is organizing her task list for the week when her phone starts ringing repeatedly. Mia. Answering IT support. This is Mia. Finance manager. Frustrated. The accounting system is practically unusable today. Reports that normally take seconds are taking minutes to run. We've got month-end closing to finish by tomorrow. Mia, I'll look into it right away. Ends call. Phone immediately rings again. Sales director, the CRM is crawling. My team can't update customer records or generate quotes. This is costing us deals. After fielding 5 similar calls in 10 minutes, Mia checks the monitoring dashboard. No alerts are showing, but clearly something is wrong. She messages Victor. Mia, multiple departments reporting severe performance issues with applications on app SRV01. Dashboard shows the server is up, but no alerts. Could you help me investigate? Victor, appearing at her desk with a mug of tea. Performance troubleshooting, perfect chance to show you how command line tools can diagnose issues that monitoring dashboards miss. Shall we? They settle at Mia's workstation. Victor, our monitoring system looks at threshold-based metrics, CPU, memory, disk space. But performance problems often hide in the details. Command line tools can help us dig deeper. Mia, where do we start? Victor, let's first establish a connection to the server and check its basic health. Copy. Ping in 4 SRV01. Output shows response times around 1 millisecond, normal for the local network. Victor, good network connectivity. Now, let's establish a remote session and begin investigating. Copy. Vinurser app SRV01 CMD. A command prompt for the remote server appears. Victor, we have a foothold. Now let's investigate what's happening on that server. Scene 2. The foundation, performance metric basics. Victor, when troubleshooting performance, we need to check the four food groups of computing resources: CPU, memory, disk, and network. Let's start with CPU. Copy. Type perf backslash processor underscore total backslash percent processor time, SC5. Output shows CPU utilization fluctuating between 30 to 40%, not abnormally high. Mia, that doesn't look too bad. Victor, CPU is often not the culprit. Let's check memory next. Copy. System info Finster /C. Total physical memory /C. Available physical memory. Output show.
Let me try to get this command. I think it will be good if we can try it. Let's see if we can get. So here is getting the physical memory and the available memory from sysinfo utility. Can this actually run? Let me see if I can implement that. Let's see this one. Actually, that's good. Okay, so he got me the total memory and the available memory. Very, very good. So now we can get, by this simple command, we can get the total physical memory and the available physical memory. So we have 6 gigabyte of RAM used now. So that's good. Let's continue the case.
Shows. Copy. Total physical memory. 16,384 megabytes available physical memory. 812 megabytes. Victor. Only 812 megabytes free out of 16 gigabytes. That's concerning. Let's dig deeper into memory usage. Copy. Task list /v/phi. Mem usage GT 100,000/FO table. Output shows several high memory consuming processes, including SQLserver.exe using over 12 gigabytes.
So this is another thing here. I need to know this is memory usage get. So this is, I think he is getting tasks that are using more than 10 gigabyte of RAM. I think this is it. Let's try to get this and ask Grok to explain it. Explain this line. Explain this line in simple terms. So let's see what this will do. So as we know, the thinking models takes a lot of time to uh, uh, just take the prompt and begin logical thinking about each part of the prompt. Okay, so let's see here. He's talking about uh, this will give us the tasks that are using 100 megabytes uh, of the RAM. So I think here let shows all program call processes currently on your computer, filter by memory. So he's getting us the tasks that are using 100 megabyte of memory and display it in a table. So that's very, very good. I need to see if also this will be I actually can leave the command prompt open and see if this commands will do further if I try to do this. So that's good. Now we see that I have uh, as you can see here we have the registry. It's taking about 131 megabyte of RAM, memory compression, Explorer. For example, here I have a troubleshooting using remote tools using command shell. I think this is for the age. These are the tabs for the age. Grok. Okay, this is also for. So most of them are for age. and each one of them is taking more than 100 gigabyte of RAM. And as you can see here, the system or the user that are using this session is currently using this session. There is me, and these are for the system. So perfect and very very good commandlets. Actually I didn't know, and actually this is one for my cam recorder. It's taking about 255 megabyte of RAM, so very very good. Let's see if it gets us more commandlets or more useful commandlets. If we go to that and continue the discussion.
Moihai gigabai. Mia, wall. SQL Server is using most of the RAM. Victor, that's actually normal for a database server. SQL Server is designed to use available memory for caching. Let's check disk performance, which is often the real bottleneck. Copy. Type perf /physical disk _total /average. Disk sec /read /physical disk _total /average. Disk sec /write sc5. Output shows read times averaging 0.3 seconds and write times averaging 0.5 seconds. Victor, frowning. Those disk response times are terrible. Good disk response time should be under 0.020 seconds. We're seeing 15-25x slower than acceptable. Mia, could that explain the application slowness? Victor, absolutely. Almost all business applications are disk I/O dependent. Let's look more closely at the disk subsystem.
So let me see something here. He is telling that the total, the average read and write should be under 0.020 seconds. This is 0.3 and 0.5. So this is more, this we see 15, just 25x slower than acceptable. So let me see also if I can see this commandlet and see, or make it and see if we can get it. This is for 5 seconds. As you can see here, this is 0.00002, so I think this is good. So less than, so I think he is correct. Even I don't have any activity, but this seems to be good. Okay, so I think he is correct about this thing. So very very good. Let's continue and see what he will do next.
Subsystem. Copy. Output shows information about the physical disks. MIC disk drive get caption, size model. Output shows information about the physical disks in the server. Victor, now let's check logical disk performance by volume. Copy. Type perf /logical disk *average. Disk sec /read \logical disk *average. Disk sec /write sc1. Output shows E drive data drive with much worse performance than C drive system.
So let's also, I think this is very very useful. I will try to go ahead with the commandlets. So now we have this commandlet again. This will get us the model of the disk drive. This is the model and the size, and actually this is 500 gigabyte, and this is the model. And then he will try to get the performance per volume. So let's try to see if this will compare my C and D partitions. Here let me try to see. Now he got most of it, read and write, so and so, logical. So we have write and read. But where is the C? So here is the D partition, and here is the C partition. But I need to comprehend this data, or to make it to appear in a good format. Let's copy it and then tell Grok to organize this data in a table and explain it in simple terms. Let's see what this data means here. Then we can do that and then try to see. So here he is arranging the data, and let's see what this means. So if I go up and see, here is the volume 1. We have this and this. We have the C, the average disk read and write. Okay, and then we have hard disk volume 3, which is my D partition. We have average disk and write, so and so. So let's read the things here: timestamp, the value, so and so, the time, logical disk, okay, hard disk. This is the main partition. So I think this also are very good things. Zeros mean that I have no read operations like opening files happening at the exact time. So they are not, they were so fast they didn't register. Okay, as for the write, we have 0.00185, super tiny. This means C drive was writing data like saving a file, took about per second, which is very fast. So total shows because it's average across all disk and C was the only one with activity. So I think here this is the volume, this is the hard disk volume, and this is C. So I think here this seems to be good. Here is comparing the read and write, and this is the total of all of them, average for all of the partitions and for every. Very good. Actually, I think this is also very logical to use. Let's continue. Actually, I begin to like this scenario. Let's continue.
System. Victor, the E drive is showing serious performance problems. Let's see what's happening on that volume. Copy. Make logical disk where caption equals E. Get caption, description, file system, size, free space. Output shows E. Drive is almost full, only 2%.
So again, let me try to get this one and just to modify it and give it, for example, the C or my D partition, and let's see also this will give us free space and something. So here we can see this is the D partition, description, file system, free space, and the size is, I think this is 300 gigabyte, and I have 204 free space. Actually, very good commandlets that will help us diagnose a lot of issues. So let's continue the case again.
Free space. Mia, surprise, is that why it's slow? I thought disk performance drops only when completely full. Victor, performance starts to degrade significantly when free space drops below 15% and gets exponentially worse below 5%. But there could be more to it. Let's check if any specific process is hammering the disk.
So again, I think this case, I need to see if uh, this phrase is correct. He's saying that performance starts to degrade significantly when free space drops below 15% and get exponentially worse below 5%. But there would be more to it. Let's check. So again, we can see here that there is a script that will be used to see if we have uh, uh, more activity to it. Let's first try to ask Grok, is this statement correct for Windows system? And let's try to read this one and see if this could be the case. So here he's giving us, he's saying that the statement is correct. One query left for Grok 3. Okay, let's read here. The statement is correct. Performance so and so. Okay, a free space decrease the file system. NTFS typically in Windows has to work harder to allocate space for new files or expand existing ones. This leads to fragmentation, so we need to have free space. Virtual memory. Windows use virtual memory to supplement RAM. If free space is too low, the paging file may not function effectively, leading to performance degradation. Okay, so this will also push or put some load on the virtual memory, which will make the performance of the hard disk also degrade. NTFS specifics. File system reserve space for the master file table, a critical structure that tracks file locations where the MTF can grow as needed. Extremely low free space can hinder its efficiency, further impacting performance. So again, this is correct. Common guidelines often echo in tech supports and user experience suggest that performance starts to degrade noticeably when free space falls below 15, below 5. The issue can become more severe as the system struggles to manage so and so. Guidelines. Uh, Microsoft and other reliable resources typically recommend keeping 10 to 20% of disk space free for optimal performance. The 15 threshold aligns with this range, and the 5 mark represents a critical point where problems can become more pronounced. And we have here 2%, so we have a large problem. These percents are widely accepted as practical rules of thumb for Windows system. Okay, so okay, so this statement is correct. If you try to see here uh, this script, what it will do, this is activity monitoring script, identifies processes of high disk activity, monitoring this activity by process. This will take about 30 seconds to gather meaningful data. We will make counter to get process the processor and the counter. He will export it and then now get current for now get the current values after our monitoring period. We'll get a baseline performance counters. We will make a baseline counter and then we will get the counters after adding our monitoring script to see if it will take some of the processes or RAM. So he will get the normal process for the processor or the normal operation, and then he will again get the process or the processor activity after using our script. Calculate the difference to find active processes. So we'll get a baseline and then we now get the current values after our monitoring period. Okay, so we'll open it and then begin seeing the activity and then find the differences, and then he will get those. And so what he will do exactly, if so, he's trying to see the normal operation, get counters for the normal operation processor, especially the processor or the process, and then see the activity, for example, by the users. So now we can get the values after our monitoring period after 30 seconds. So this is the baseline collecting data. Now we can get the current values after our monitoring period. Okay, so he will monitor it for 30 seconds. Then after that, he will export it. Okay, I think I cannot understand this. So let me copy this and try to ask this time Grok again to explain this script in simple terms. This is script in simple terms. And let's see how he will explain that. So explaining each line in the script, I need to have the summary or to get the summary for the script. Simplified summary. So takes a snapshot of disk activity, waits 30 seconds, and then take another snapshot. Compare them to see what programs use the disk the most. So he first take a snapshot during or normal activity, during the normal activity, and then wait for 30 seconds and then take another snapshot. This snapshot I think will include the programs that are making a high activity on the hard disk to know what is the problem. Okay, compare them to see which programs used the disk the most. Show the top 10 readers and top 10 writers in easy to read format. Clean up and says done. So I think this is a good one. If you get the script, this is a PowerShell commandlet, or this is a batch file. So where he will put the file in the ctemp, and then okay, let me try to see if we get this one and try to put it in a batch file and try to run it. Let's do that. So if we get this and do like that, okay, and then we put like this, then file save, then we can name it activity or disk activity monitoring script, copy, and then we can close this one and then rename it to monitoring this activity .bat BAT, and there it is. And now this is a very good one actually, just to monitor the disk activity. Just a moment, guys. So let's continue, guys. Let's see the rest, or continue reading the script, reading the case.
Victor, I've created a script that will monitor disk activity by process for 30 seconds. Let's run it on app SRV01. Copy. Winners are app SRV01 CMD /C McDeer C:\temp2 null and copy disk activity script. The bat C:\temp / and C:\temp /disk -activity -script bat. The script runs and eventually shows output with a surprising result. Skullbackup.exe is showing massive disk write activity, along with several instances of SkullServer.exe showing high read activity. Mia, pointing at the screen, SQL Backup is writing at 95 megabytes per second. Is a backup running during business hours? Victor, that shouldn't happen. Backups should run after hours. Let's check the SQL Server agent jobs. Copy. Winners are app SRV01 PowerShell, command invoke SQL CMD, query select name, enabled active _start_time from MSDB, DBO sysjobs j join MSDB. The DBO sysjob schedules JS on j dot job underscore ID equals JS job underscore ID where j dot name like percent backup percent server instance app SRV01. Output shows a full database backup job scheduled to start at 10 a.m. daily, right in the middle of business hours. Mia, there's our first.
So here he's saying that this will get the SQL Server agent jobs. So this is for the SQL agent jobs or backup jobs. He is saying that this will query the SQL for the backup jobs that are created here. So let me try also to copy this and try to see what that it means exactly. If we go to ChatGPT to explain, or let me okay, we can get that. Just a moment. Explain this line in simple terms. Let's see this. So we here see that SQL commands invoke to run a SQL query against a SQL server, and SQL query details. Select the job name while the job is enabled and the job schedule start time. So he's querying for backup jobs, and he need to display the job name if it is enabled and the schedule start time. It does this by joining tables for sysjobs and sysjob schedules. These are two tables in the SQL database that contains the backup jobs as far as I can comprehend, and filtering to include only jobs whose name contain the word backup. So that's good. In simple terms, the command remotely connects to a server, runs a PowerShell script that executes a SQL query and returns details about backup related SQL jobs. So that's good. Uh, so that's correct one. Let's continue and see how this case will go.
First problem. Someone must have changed the backup schedule. Victor, good catch. And there's likely more going on. Let's check what else is consuming the E drive. Copy. Winners are app SRV01DR E colon backslash slash S slash A Finster slash I bytes free. Output shows numerous large log files and several folders with old backup files. Mia, the drive is cluttered with old log files and backups that should have been moved to archive storage.
So again, I need to see this commandlet. If I try to get it here, copy, he will get the free bytes. What this will do exactly? Again, let's tell him to explain this line in simple terms. Well, let's put it like this. So this lists all files and folders on the E drive, including hidden and system files, and it goes through all subdirectories. The pipeline sends the output to find bytes free, which looks through that list to find a line that mentions how many bytes free are there are. A growing case. In simple, it shows you the free disk space on E by listing everything and then filtering to just display the free space line. I think I cannot understand it. Let me try to use it here in my this one and try to put my D partition maybe. Let's see how this will go and see if it will work. So it's getting all of the files. This seems to be, so what this means. So we have 51 files. Uh, mm, well, I don't comprehend exactly. Here we have 51 files, and then uh, I cannot see here what this means. So we have, okay, so it's listing, uh, but I think should filter with the 0 bytes. Okay, so I think here is listing all of the files, and he is giving us the all of the files on the partition, and each one uh, total of. So I think this is a good one, but I think it can be tweaked. Let me see. So it lists all of the files here. We have a lot of files. Okay, so it's getting us a lot of files that are listed, but I think here we have no, I think this should be enhanced. I need to enhance it a little bit. uh, can you enhance this script to work and display output in simple, in organized format? Let's see. So let's see here. So let's see this one. Save the temporary file, loop for clean, temporary delete, pause. So he didn't do much actually. Uh, mm, so again, I cannot know why this is used. So here he's getting the files, every file, and it's uh, okay. Then let's tweak it a little bit, or let's do it with a simple. I need a script to list all files in a partition and give uh, the size uh, of it and output in a table. So this script will get us all of the files, will gather details and display them in a tabular format. Then we can see here is the script. I think let me try to put it in PowerShell commandlet. Now we can do this and open. And now we can have this, so we can do that and put it like this and try to put my D partition, and let's do that and see how it will work. So I have a lot of files actually. So again, there is a problem with the command LGB is not recognized as something, but here he listed all of the files, but uh, without the size of files on drive. So he get all of the files, but without the space. Okay, so and there is a problem with this one. Uh, let's give it this error. Okay, I have got this error, and I need the size of each file. Export to CSV file. So here this is the one, and as for export, where is the path? CSV path. Okay, let's get this one and try to put it, let's CLS, and then put this script, and then let's do like this, and let's put it on D, or let's put it in C actually. We'll do like this and try to see if it will get what you need. So let's try to run it. So we have total size of files on D is 7796 gigabytes. These are the files, okay. And let me see where he exported the files. Let me go and read it. Here is for this PC and see where is the file. File lists. Here you go. This is the file list, and let's try to see what does it contain. So here he got the folder. Let's wait for a moment. Now we have each folder and the size in gigabytes. So these are the folders. Okay, these are the files. So I think for example here I have, this is 0.3.003 gigabyte. I think this is for 30. There is, for example, some videos I have, so it have all of the files listed, but 2 gigabytes. So these are the small files, but it's good, it will get us the large files. So if I go, for example, further here to this PDF, for example, let's see its size. It's 0. Actually, it's giving it 2 gigabyte, which will be not that good. Okay, let me modify it to let's modify the script to put it to megabyte. Size n, let's get it to megabyte, and let's get this to megabyte and see. Let's do that again and see if this will work. Now we can do this. That cannot be found input objects. Okay, let's ask it to modify it. Modify script to display and export size of files in megabyte. So let's try to see. I did this already. So let's try to copy it and try to see if this will work. Here you go. Now we can do this and do like this. And here you go. Now we can do that and put the D and try to run the script. So where it will put the file, it will put it. Okay, so we need to put it on C dot slash and try to do like this and again run the script. So let's go and read the files. Here you go. Now we can open this and open the C. I would have file. Here, this is the one. So now we have it in megabytes. So that's good. Now we have files in megabytes. We can see the files, and now we can filter it. So I think this is very good. Now we have list of files, and now we can see what are the files taking space. But first, let me go and hide my files, view, and then we hide protected files, applying OK. So let's continue with the case.
Troubleshooting by remote administration.
Sorry guys, this was not that good. We will go further again. Here, where is the okay, where is the mysterious network traffic? Now get further. Let's wait for a moment. mean, sorry guys. Mhm.
Storage. Victor, let's also check for fragmentation, another common cause of disk slowness. Copy. Vire epi SEH V0 defrage wa. Output shows E. Drive is 63% fragmented, extremely high. Victor, we found several problems. An ill-timed backup job, nearly full disk, significant fragmentation, and improper retention of old files. Let's check one more thing. Are there any long-running SQL queries that might be causing problems? Copy.
So let's first see what this command let mean. I know this is defrag/a, but what does this mean? Uh, Explain this in simple terms. Okay, so this /a means it will diagnose the partition without defragmenting it. So this is a good one. So let's okay, so this is a good one to know if you have fragmented hard disk or not. This is to analyze the hard disk for fragmentation. Okay, so that's good. If we continue with the case, let's see how much time we have. So I think let's continue with this one. So he's querying for long uh, SQL queries. Okay, let's read it loudly.
Troubleshooting by remote administration.
Again, he got from the start. Let me go further. With the sluggish case, and then let's read uh, then let's wait for a moment. This is the fragmentation, and then we read this one.
Winners are app, SRV0, 1 PowerShell, command invoke SQL CMD, query select session underscore ID, start underscore time, command percent underscore complete, estimated underscore completion underscore time from sys, demo underscore requests were command like percent backup percent, server instance app, SRV01. Output confirms a backup is in progress, 45% complete, with estimated completion in another 30 minutes. Scene 3. The challenge escalation, root cause analysis. Mia, so we have several issues. How do we decide what to fix first? Victor, good question. Let's prioritize. The running backup is causing immediate performance problems. The nearly full disk needs space cleared. The severe fragmentation needs to be addressed. The backup schedule needs to be fixed. Mia, should we just cancel the running backup? Victor, that can cause its own problems. Let's check how much longer it has. Copy. Winners are app, SRV01 PowerShell, command invoke SQL CMD, query select session underscore ID, command percent underscore complete, estimated underscore completion underscore time, slash 60,000 S estimated minutes underscore remaining from sys, dem underscore requests were command like percent backup percent, server instance app, SRV01. Output shows about 28 minutes remaining. Victor, unless the business impact is severe, it's usually better to let a backup finish than to cancel it. While it completes, let's work on identifying files we can safely remove to free up space. Copy. Winners are app, SAR01 PowerShell, command get child item, path, /log single quote, filter star.log, recurse where object $and last write time, lt get date, add days -30, measure object, property length, some select object at name equals older than 30 days, expression equals math : round $_, some /1 gigabyte, 2, format table, auto size. Output shows over 120 gigabytes of log files older than 30 days.
Let me try to also use this commandlet. So we make CLS. But let's first this is to run through PowerShell, but we need to, so this will run PowerShell, and then it will log it, the logs. Let me see if this will get files older than or not used for 30 days. Let's see if this will work. Okay, so we go to dlogs and see if we have this already done. If we have logs, we have to the D, and then we have logs. Where is the logs? We don't have a folder called logs, so I think maybe we need to give it something. Let's change it to let me put it for example D only. So so what this will do, if we take it on the D partition, what this will do exactly, if we put it on the D partition, filter so and so, get date with measure so and so, format. Okay, this will get the files older than 30 days in a certain folder, but here I need it for the whole partition. Let's see how this will do. 0.01. So this, what it means exactly, shows output over 120 GB of log files older than 30 days. So here I have only 0.01 older than 30 days. This seems okay. So this is .log. Okay, so we need to filter. He is having a certain criteria to see the D partition and the log files and see what files are older or what not accessed for 30 days, so he can delete them without or delete them safely. So I think this is a good one also. Okay, anyway, so I now got the script. Let's continue.
30 days. Victor found 120 gigabytes of old log files. Now let's check for old backups. Copy. Winners are app, SRV01 PowerShell, command get child item, path, /SQL backups single quote, filter star.bach, recurse where object $, last write time, lt get date, add days, -14, measure object, property length, some select object and name equals older than 14 days, expression equals math : round, $_, some /1 gigabyte, 2, format table, auto size. Output shows about 85 gigabytes of backup files older than 14 days. Mia, that's over 200 gigabytes we could potentially free up What about the fragmentation? Victor, defragmentation requires significant disk activity, so we'll schedule that for after hours. But first, we should develop a plan to address all these issues. Mia, thoughtful. So our immediate solution is to let the backup finish while we prepare to clean up space, then defragment after hours, and finally fix the backup schedule? Victor, exactly. Let's also check if there are any SQL Server configuration issues contributing to the problem. Copy. Winners are app, SRV01 PowerShell, command invoke SQL CMD, query select name, value and use from sys, dot configurations where name in, max server memory, MB, min server memory, MB, server instance app, SRV01. Output shows max server memory set to 0, unlimited, and min server memory at default. Victor, SQL Server is configured to use as much memory as possible, which is fine for a dedicated database server, but not ideal for a multi-purpose application server. We should add that to our fix list. Scene 4, Guided Practice, Implementing Solutions. Victor, now it's your turn, Mia. Let's start implementing solutions. First, let's create a cleanup script to safely archive and remove old files. Mia, thinking, I'll need to identify old files, copy them to an archive location, verify the copy, then delete the originals.
I think this is getting much, much better. The script or the case is magnificent from my point of view. So here it says it will copy the files to an archive location, and then after copying it, it will be deleted. So here we will put the archive share, the path, and then so if we go step by step for the script is saying that first of all uh, putting the server name and then the archive share, and then it will begin displaying this cleanup and archive from server so and so. So we will create folders on the archive share if it is not there, and this one for the share and logs and SQL. So this one for the logs, it will copy the logs to this folder on the share server, and the backups also. And then we check disk space before cleanup. This is a good one to see how much space we have, and then archive and remove all log files, processing log files older than 30 days. So he will see log files older than 30 days and backup files older than 14 days, and then I think he will begin to what he will do, clean up temporary SQL Server files. So I think he's freeing some space, uh, so he's cleaning up SQL Server files, also temporary files older than 7 days, log files, temporary log files, and then check for disk space after cleanup. Okay, and then schedule for defragmentation at 2 a.m. cleanup and so. But here, where is the copy process? So here, what he will do, so I think he will get them and then plus count plus mass, so and so, set folder. So yes, I think this is the whole path he is copying and then deleting. Yes, this is, yes, he copy item, and then I think after that he will delete them. So this is all in one file, or it is one command. Very, very good. So now he is removing the log files and the backup jobs, and he is cleaning the SQL temporary log files. I think this is good, very, very good script, and he is going to make a defragment at 2 a.m. Very, very good. Let's continue and read the case.
Victor, Excellent work. That script handles the file cleanup systematically. Let's run it. Copy. Disk cleanup script.badapp srv01 //backup -srv01 /archives. The script begins running, archiving and removing old files. Victor, while that's running, let's prepare a script to properly configure SQL Server memory usage. Mia, typing, I'll give this a try. Copy. Winners are app, srv01 PowerShell, command invoke SQL CMD, query exec_configure, show advanced options, 1, reconfigure, exec_configure, max server memory, MB, 8192, reconfigure, server instance app, srv01. The command successfully executes, limiting SQL Server to 8 gigabytes of RAM. Victor, perfect. Now SQL Server will use at most 8 gigabytes of RAM, leaving adequate memory for other processes. Now let's fix the backup schedule. Mia, with growing confidence, I'll modify the SQL backup job. Copy. Winners are app, srv01 PowerShell, command invoke SQL CMD, query use MSDB, exec MSDB to DBO SVN through job schedule at job_name equals full database backup at name equals daily full backup at active_start_time equals 220000 server instance app srv01. Command successfully changes the backup schedule to 10 p.m. Victor, excellent. And finally, let's create a monitoring script to warn us of potential disk space issues before they become critical. Disk space monitoring script.
So let's see the script. So now again, this is to monitor us when the disk space is getting low. We have threshold of 15, and then we have 10, which is critical, and then send an email when it reaches the critical threshold. Set alert at 4%. So just a moment. So we have critical threshold 15, 10, and then it will send an email when it, I think, reaches 10. Maybe let's go and continue here. It will send an email warning. So free space, this is the email. So anyway, this is a simple one. If we go and read or continue reading the case from here.
Mia, this is great. Let's create a server list file and set it up. Copy. Echo app, srv01 servers.txt echo app, srv02 servers.txt echo db, srv01 servers.txt echo web, srv01 servers.txt disk space monitor bat servers txt 1510 at -alerts at company.com. The script runs and shows the current disk space status across all servers. Scene 5. The Complexity Crucible Performance Validation. 2 hours later, after the cleanup script has finished and the full backup has completed. Victor, now let's validate our changes and make sure performance has improved. Copy. Winners are app, srv01 MIC logical disk where caption equals E. Get caption free space size. Output shows the E. Drive now has 42% free space, a dramatic improvement. Victor, much better. Now let's check current disk performance. Copy. Winners are app, srv01 typeperf /physical disk _total /average, disk sec/read /physical disk _total /average, disk sec/write, SC5. Output shows read times around 0.025 seconds and write times around 0.035 seconds. Still elevated, but much better. Mia, that's a big improvement, but still not ideal. Victor, the defragmentation tonight should improve it further. Let's check memory usage now. Copy. Winners are app, SRV01 system info Finster/C, total physical memory/C, available physical memory. Output shows 16,384 megabytes total and 7,426 megabytes available, a dramatic improvement. Victor, our SQL Server memory configuration has freed up significant RAM. Let's verify there are no remaining backup jobs running. Copy. Winners are app, SRV01 PowerShell, command invoke SQL CMD, query select session_d, command from sys, requests were command like %backup server instance app, SRV01. No output, no backup jobs are running. Mia, smiling. We should check with the users to see if performance has improved for them too. She calls the finance manager. Finance manager, surprised whatever you did worked? Reports are running quickly again. Thank you. After ending the call, Mia turns to Victor. Mia, it worked, but how do we make sure this doesn't happen again? Scene 6, the integration, long-term solutions. Victor, good question. Let's implement some long-term safeguards and document our troubleshooting process. Mia, I think we need regular disk space monitoring with alerts before space gets critically low. A proper backup retention policy. Automated log cleanup. Regular defragmentation. Victor, excellent list. Let's create a comprehensive performance maintenance script that incorporates all these elements.
So this is the script. As you can see here, this will do a lot of things actually. Here we have log retention, backup retention, disk space, alert threshold, minimum SQL temp space, minimal SQL memory, archive location. So I think this will solve a lot of issues concerning the backup and logs retention. So you can see here, this is the logs location. We have check and report disk space, clean up all log files, clean up all backup files, check and optimize SQL Server if installed, optimizing configuration, setting maximum memory, and this we have done before. Clean up SQL Server error logs just to free some space. Check temp DB free space, temporary database free space. So I think also this can free some space. This is SQL optimization, so this is free some space. Configuration and configuration of the SQL memory, removing all SQL logs, deleting some files from the temp database, check disk fragmentation schedule if needed, check and clear event logs if too large. This is on the C partition, but this also can help to free some space, but this is on the C partition. I don't think this will help. And then send an email, email the log file if email parameters are configured, add more code to send, add code here to send email with log files attached. Anyway, so I think also this is a good script. Let's continue with the case, and then he will run this script through schedule task.
Victor, excellent. Now let's schedule this maintenance script to run daily. Copy. Winners are app, SRV01 stas/create/tn daily server maintenance /tr c:\/scripts/server-maintenance.bat/sc daily/sd1 o'clock/ru system. Mia, thoughtfully, this is comprehensive, but we should also create documentation about our troubleshooting process to share with the team. Victor, good point. Let's also create a formal performance troubleshooting guide.
So here also giving us a troubleshooting guide, which is perfect from my point of view. The eye is going nuts. It's giving us a lot of useful information and even some guidelines and some documentation. For example, basic health check. The ping, this is like a summary, pinging and going, checking the processor, checking the memory. All of these are very, very good troubleshooting systematic steps. When did the problem start? What applications are affected? Checking conductivity, all we have done before. System boot, checking running services, analyze CPU usage, and memory analysis, identify memory intensive processes. All of these he have done before, but now he's giving us documentation. Disk analysis, check for performance, disk analysis, disk space, check fragmentation. All of this he have done before. Check network connections to the server or the SQL server. Identify network intensive processes. If there is connection to the SQL database, check network performance, application specific analysis, check running queries. All of this we have done before. Check backup status, SQL. All of this he have done already and put them in a very, very professional troubleshooting guide. Okay, consistently above 80 bottlenecks, memory bottlenecks. Actually, very, very, very good one. Okay, as we can see here, uh, a lot of things here is putting memory solution, restart memory leaking application, limit SQL memory usage. We have seen this. Clean up temporary files just to free space on the C partition if this is the case. Archive and remove all logs. We have seen all of these. Uh, Cancel long running SQL backups, schedule backups. All of this we have seen. Implement preventive measures, schedule regular maintenance tasks, performance benchmarks. Use these guidelines when evaluating server performance, CPU usage. Oh my god, this is good. Warning, perfect, 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 perfect. Comprehensive maintenance script. We have seen this. And reference. Very, very professional troubleshooting guide actually. I am very impressed. Okay, let's try to read and continue the case.
Victor, this comprehensive guide will help not just us, but the entire IT team troubleshoot performance issues more effectively. Let's make it available on the Team Wiki. Mia, looking at the performance troubleshooting guide, this is amazing. It covers all the steps we took today, but also many other scenarios we might encounter. I'll review it thoroughly tonight.
So very, very good case. I think this also one of the good cases created by Claude, and I think it's also better than the other two cases. But perfect, perfect, perfect. I am just amazed how this case is created and how it is looks very, very real. So I think we are finished with this case today, and I think we are finished with the topic of troubleshooting Windows using remote tools and remote commandlets or remote CMD commandlets. Until we have another good or another topic in the upcoming video with God will. Hope this video informative for you all and thank you all for viewing. Thank you so much.